Hello everyone, welcome to part 5 in our series on the derivative. Today we're going to be talking about the quotient rule. What is the quotient rule? Well, the quotient rule says that if I have a function h of x and it's equal to f of x over g of x, the quotient rule is going to tell us how to get the derivative of h of x. Okay, I'm just going to give it to you. Here we go. H prime of x, that's the derivative of h of x, equals, okay, we're going to get a big fraction. In the denominator, we're going to put g of x squared. In the numerator, I'm going to get g of x times f prime of x minus f of x times g prime of x. That's it. That is what we call the quotient rule. Okay, well, that's kind of a big expression to memorize, right? So there are some nicer ways to write this, and there's some mnemonics out there that we can go over. Okay, I usually think of this as f over g prime equals g squared goes on the bottom, so the denominator here becomes squared in the denominator here when we take the derivative. In the numerator, I start with g and I multiply by f prime minus f times g prime. So the numerator starts with a g and ends with something with g in it. And you just have to remember the minus sign. So I just think of it as, okay, the g squared goes in the bottom. I start the top with the g, and then it's kind of like the product rule, except it's got a minus sign. Now, there are mnemonics for these things. There's probably many of them. I'm just going to give you the one that I like. If we think of this derivative as high over ho, then we can remember this quotient rule by saying, just saying in order, ho d high minus high d ho over ho ho. That's it. That's a little clever mnemonic for the quotient rule. What I like about this mnemonic is the ho ho in the denominator. I think that's kind of funny. Why do I think it's funny? Well, ho-hos are actually a delicious little chocolate snack that you can buy. And in fact, in the year I'm recording this, 2020, ho-hos are actually 100 years old. Don't believe me? Look it up on Wikipedia. Okay, let's get to some examples. If you watched our video on the product rule, I did examples where we kind of knew the answer ahead of time, and I think I'm going to do that again. So let's try it. H of x equals 1 over x. Okay, we want to find the derivative of this. Now first you might be thinking, why am I using h and not f? Because that's what we usually take the derivative of. I'm just doing that right now. Eventually I can drop that once you become more comfortable. But I want to identify the function in the numerator as f of x, and I want to define the function in the denominator as g of x. Okay, so I didn't want to have an f of x here and an f of x here. Okay, well, let's go ahead and use our quotient rule. H prime of x is going to be, so as usual, I draw a nice big fraction. What goes in the bottom of the fraction? Just this denominator squared. Well, that's just x squared. The numerator starts with that same function, x, times the derivative of f. Well, what's the derivative of 1? The derivative of any constant is 0. Now, don't forget the minus sign. Now I switch which I'm taking the derivative of. F times the derivative of g. What is the derivative of g? Derivative of x is 1. So I get 1 times 1. Okay, that wasn't so bad. What do I get? Minus 1 over x squared. Now, you might be thinking, wait, we didn't have to go through all that trouble. I could have written h of x as x to the minus 1. And then I simply need to use my power rule, which says that h prime of x is bring down the minus 1 times x, reduce the power by 1, minus 2. Well, that's the same thing as minus 1 over x squared, which is in fact exactly what we got before. And as you get more comfortable with calculus and derivatives, you're going to find that if you see this, you really are going to want to think of it like this. This is the fastest way to get this particular derivative. We didn't really need the quotient rule. But the reason I use the quotient rule is that 1, it was an easy example, and 2, this hopefully gives you some confidence that the quotient rule is doing the right thing because we actually got the right answer. What if I had just taken the derivative of f and divided by the derivative of g? I would have gotten 0 over 1, which equals 0. Well, that's clearly not the right answer. So that's kind of our wishful thinking quotient rule, and unfortunately, that just isn't right. Okay, let's move on to another example. Let's try h of x equals x over 1 plus x. Okay, so as before, this is what I identified as f of x, that's this. G of x is my denominator. Okay, so let's use our quotient rule. H prime of x equals, okay, big fraction line again. First, I take the g function, the denominator of my original function, and I square that. Square the whole thing. Next, I bring that function up, of course without the square, because that's what g is. G times the derivative of f, the derivative of x is 1, subtract f of x times, what's the derivative of g, which is 1 plus x? The derivative of this is 0 plus 1, or 1. There we go. Well, that's not so bad. If you look at the numerator here, I have 1 plus x minus x. That's what I get. 1 plus x minus x, the x's cancel, I just get 1. And my denominator, well, there's not much I need to do with that. That's the answer. Now, sometimes you'll talk to someone who's more experienced in calculus, and they'll say, oh, I never use the quotient rule. All I do is use the product rule, and I rewrite a function like this. So, for example, we could have rewritten h as x times 1 plus x to the minus 1, and then you can treat this function as f of x and this function as g of x and use the product rule. And actually, that's completely correct. You can do that. I didn't do it that way because, again, this is a video about the quotient rule. But if you want to do this using product rule, you can actually always do that. Okay, let's do a final example. Okay, now this is more of a word problem. And this is a classic thing to do with derivatives. So we want to find the equation of the tangent line to the function h of x equals x over 1 plus x at x equals 1. Okay. So whatever this curve looks like, at x equals 1, it's going to have a tangent line. Remember, that essentially is going to tell us the slope of this curve. The tangent line slope is the same as the slope of this curve, and we have to find the equation of it. Well, the first thing to figure out the equation of a line is to determine the slope of that line. To get the slope of that tangent line, well, that's the same as the derivative evaluated at x equals 1. Well, it's kind of convenient, isn't it, that the previous example we just did was, in fact, to find h prime of this function. What result did we get? We just got this nice thing right here. Okay, that means that h prime of 1, which is in fact the slope of the tangent line, is going to be 1 over 1 plus 1 quantity squared. Well, that's 2 squared. That's 1/4. All right, let's keep going. So I'm not going to try to draw this curve. Let's just pretend it looks like this. Okay, and here's x equals 1. What point is this? How do I get the y value of the point that the tangent line is going to go through? I'm going to try to draw a tangent line here. Okay, there's my tangent line. In order to find the equation of the tangent line, I need to know what is this point that the line goes through. I know its slope, it's 1/4, but I need to know what is the point right there. Well, I know that the x value is 1. The y value comes from the curve. I just need to plug in x equals 1 right here. 1 over 1 plus 1, that's 1/2. So this point right here is 1/1/2. That's really all we need. We have a point on the line. We have the slope of the line. So I can write down the equation of the line using what's called point-slope form. Point-slope form is y minus y1 equals slope x minus x1, where x1, y1 is the point on the line, and the slope, well, that's of course the slope of the line, which we have right here. So I've got my answer. It's going to be y minus 1/2 equals 1/4 x minus 1. That's my answer. You can simplify this, but this is actually perfectly good as is. That is the equation of the tangent line. Well, that's it for this video. Hope you enjoyed it, and I'll see you next time.